So what is a Punnett square? I've been drawing these things up for the last few slides here. What is a Punnett square? A Punnett square is this. It's a table. Shows all the possible genotypes and all of the potential first, second, whatever, but it shows all the results that can happen from those specific alleles, from those specific genes. You can do it however you want, okay? I always put, you can put them all, but just, I always put the female on top, okay? And put her, let's just say big A, okay? And I always put the male on the side, okay? Little a, little a. And then obviously within the field here, and I'll use a different color, okay? Just use blue, okay? Big A, little a, big A, little a, big A, little a, big A, little a, okay? So the blue is all of the potential zygotes, okay? Okay, they're placed within the squares, all right? That's the F1 generation, okay? That first cross, all right? So these are all the zygote possibilities of mom and dad coming together. And we use this to determine the probability for what parents can potentially have, okay? And that's really kind of the big thing, okay? It's a probability. It doesn't mean that, you know, all of the children are going to, you know, be this, or I guess kind of the best way to do it would have been like this, okay? It's too big. Okay, what if I do big A, little a? Big A, little a. Okay, sorry. Oh my God. Pause. Big A, little a, big A, little a. Mom on top, dad on the side. Okay. So here are. Okay. Doesn't mean they're going to have one child that is homozygous dominant, one child that's homozygous recessive, and two that are heterozygous. It means that they will have a chance of having a genotypic ratio of 25% to 50% to 25%. Okay. 25% homodominant, 50% heterozygous, and 25% homozygous recessive. Okay. And that every time they have an offspring, it's always going to be that. Okay. So it gives us that breakdown. All right. 1/4, 1/4, 25%, 25%. These are the same thing. So that is 1/2. Okay. A quarter plus a quarter is a half. Okay. Now the biggest thing to remember here, guys, and I'll go over here to this picture. Okay. I'll give you the allele key. I'll tell you what's dominant and what's recessive. You need to pay attention to what am I asking for? Am I asking for the genotypic ratio or the phenotypic ratio? What are the genes and what do you see? Okay. It should be a fairly easy question, a very easy question. But for whatever reason, people don't read the whole dang question and screw that up. Okay. So here you can see attached earlobes are recessive. Okay. Both of them were carriers. Okay. Both of them have the heterozygous. 1/4 of them have a genotypic ratio of little e, little e. 1/4 of them have, or 25%, have a phenotypic ratio of having attached earlobes. Okay. How many have unattached earlobes? Well, that would be 75%. But how many have a genotypic ratio of a heterozygous attached earlobe? And that would be 50%. Okay, big E, little e. Okay. So by asking those questions like that, you have to know what a genotype is, what the definition of it is, what a phenotypic ratio, or I'm sorry, what a phenotype is. Okay. You need to be able to understand all those words. Okay. So I could ask it in a question, which is basically applying what you know. And, we just call it a test cross. I mean, these Punnett squares, if I give you some kind of, written question, this is just what you put it in a Punnett square. And they just call it a test cross. That's all. See, that's all it is. Here's 2 trait test crosses, 1 trait. I mean, that's all that is.